In section 1.3, we learned how to describe transformations. And it's important that when we're describing transformations, we're specific. And we have three types of rigid transformations that we're talking about. We have a translation. And so a translation we describe we need to describe the horizontal and the vertical movement. So we need to be specific with the x direction and the y direction, how far up, down, left, or right. And we can use the rules as well, x plus something like 3 and y minus 2 to tell the direction it's moving. So when we have a translation, we need to tell the direction, both horizontal and vertical. When we have a reflection, we need to define the line of reflection, and that's usually going to be with an equation. All right, so we want to define the line of reflection. And once we define the line of reflection, everything else falls into place. You just need to tell what the equation is. And then last but not least, if we have a rotation, we need to define the center of rotation. All right, rotation. So what are the coordinates of that center of rotation? And we also need to define the direction of the rotation. And we need to define the angle of rotation. So how many degrees are we going to rotate it? All right? So we need all three of those things for a rotation. Okay? We need to find the center, direction, and angle. All right? Now, when we're describing things, it's useful to use some of this vocabulary. We can say that one thing coincides. So we can say move an object until 2 points coincide, or two sides coincide. That means that they're at the same place. All right? So if I have a triangle here, and I have A, B, C, and let's say I want to copy that. And so we take the new triangle here, and let's call that A prime, B prime, C prime. So we might say, if you want to translate this or describe the translation, we can move this until, let's put this on top. Okay. We can move this until the A corresponds to the A, or whatever it may be. All right. And more often we'll have more going on. But coincides means two things line up. Corresponding points mean they're in the same location. So points, sides, and angles are corresponding. It just means they have the same relative position. Okay? And again, orientation is kind of the order in which a figure is labeled. So the orientation is the order that we name it in. So this is like triangle ABC. All right, well, let's try a few examples here, all right? So if we want to create a sequence of transformations to get the object from the pre-image to the image. So we have this red one, which is Q prime, R prime, S prime, and P prime. Can you tell what kind of transformation this is? It looks like it's just a slide. So we're going to take this and we're going to slide it to the right and up, or we could go up and to the right. So how far are we going? Looks like we're going over here, so we can just pick one of those points there. And if we pick one of those particular points, like Q, for example, Q is going to come over here, and then it's going to go up. So how far is that? Looks like it's going right 5 and up 5. So right 5 and up 5 is an okay way to describe this. Once again, though, we're going from the non-prime to the prime. The prime means the new one. using a rule, we could say xy goes to x plus 5, because we're going right 5. That adds to the x value. And then y plus 5. Going right adds to the y value, right? Or I'm sorry, going up adds to the y value. All right? Well, what's going on here? Well, looks like this triangle is flipping. Can you see that? So we have a reflection, and the way that we can tell that is if we connect R and R, T and T prime here. Let's see if I can make that a little better there. We have T and T prime. There we go. And then we have S and S prime. So notice those are parallel lines, and if we find the midpoint, the point right in the middle of each of those, that's where the line of reflection is. The line of reflection is the origin. So we're going to reflect across, sorry, not the origin, but across the y-axis. Okay? So they're flipping across the y-axis. So one point will go to the y-axis and across. This t will go to the right y-axis and across, and we come over here at t prime. So on and so forth, all right? Well, what's going on here, all right? So we got a little bit more going on here. Notice we got this L here. It's kind of on the left side of this shape. Well, this L is at the top. So we need to describe this a little more carefully. So what can we do? Well, we can take this shape, and first thing we want to do is we can translate it so that the L, this old L, coincides with the new L, the L prime. Then we need to do some rotating here, right? So we're going to need to swing this around. So this is L, this is M, this is N, this is K, as it moved on up there, right? You see that? And we need to rotate it until K matches with this K prime, okay? So we're going to rotate it about the point L. We're going to spin this around so that the points land in their place. So right now we're not worried about exactly how many degrees that is. We can just describe it as rotating. We can rotate about the point L prime. So we're going to rotate about that until the points, let's say this, the pre-image coincides with the image. Okay? All right, so if we do that, then this will swing around there, and we'll end up with something like this. We'll swing this around, and that will line up right here. This K will go to this K. This, what is that there? N will go over to this N, and this M will go over to this M, and the one we're rotating around point L here, will stay the same. All right, so that's the idea. Okay, so we can describe it with one or two or multiple transformations there. On the next page, we've got just some practice here, so let's look through this together. This is our retrieval. So for each of these equations, we want to write the slope of a parallel line to the given line, and the slope of a perpendicular line to the given line, all right? Well, let's look at this. What's the slope of this line? Well, the slope of this line is, this is in y equals mx plus b. So m, the slope, is 2/3. So the parallel line will have a slope of 2/3. The perpendicular slope will flip and become the opposite, right? Okay. Now, on this one, we've got to be careful because it's not solved for y. So we are going to have to solve this for y. So we can do that by subtracting 3x from both sides. And we end up with negative 4y equals negative 3x plus 6. You could also say 6 minus 3x would be fine also. And then we got one more step. We got to get that negative 4 out of there, so let's divide by negative 4. You need to divide everything by negative 4, all right? And that leaves us with y equals negative 3 divided by negative 4. These negatives cancel, so it's 3/4 x plus 6/4. We don't really care about the 6/4, so just leave it alone. What we do care about is the slope here being 3/4. So that slope is 3/4. So our parallel slope is going to be 3/4. Okay? It stayed the same, just like up here stayed the same. And then the perpendicular slope, we're going to flip that fraction. And we're going to put the 4 over 3, and we got to change the sign. It's going to be negative. So if you have a line that's 3/4, the perpendicular line will have a slope of negative 4/3, all right? And last one here, if we take a couple points like negative 2, 3, negative 2, 3, there it is, and 4, 5, 4, 5, there it is. And we want to do this. We want to plot the points on the grid. We just did that, check. We want to find the slope between these two, okay. So we're doing a rise of 2 and a run of 6. All right, so the slope is 2 over 6. And then we want to use the Pythagorean theorem to find the distance between this. Let's call this C. What is the length of that line? Okay, and if you draw in your slope like this, you can see we got a right triangle. So the Pythagorean theorem will give that to us. 2 squared plus 6 squared equals C squared. So 4 plus 36 equals C squared. Combine those, we get 50 equals C squared. And what's our last step? Our last step is going to be square root. So C is the square root of 50. Hopefully you're showing your steps, something like I just did here. Are you working through your steps and showing that? If you just put the answer, it's not quite right. Okay, now this is a decimal number. If you punch in your calculator, you'll get something like 7, because 7 times 7 is 49. So this is like 7 point something, 7.01 or something like that. So the length in between is exactly the square root of 50. That's the length in between those 2 points, about 7.01 or something like that. So there you have it. There's some retrieval, a little review on some things, and a good reminder of how we can use transformations to describe the movement of one object to another. Thanks a lot. Keep working hard.